Hey everyone, it's lesson number 4, percent increase and decrease. So we have a rather specific formula that we end up using here. And well, here's how it works. We take the change, all right, and we divide it by the original, all right, and that will result in our percent. Now, it's actually going to result in a decimal because, well, it's a fraction, and we'll change it into a decimal and then change it to percent, or we can just change that fraction right into a percent as well. So it's kind of your call here of what you would like to do. But again, change divided by the original will always give us the percent of change. For those of you at home and maybe you see the stock market stuff that's on there, and at the bottom they have these percent of change. I use this all the time from that standpoint. Yeah, hey, look at this. There's our percent equation that we've been using here. All right. Boo to that X for that multiplication symbol. That's not something that we like that's there. But yeah, they talk about the amount of the increase. Again, the change, because if it increases, it's a positive, and decreases, it's negative, but it's still the change that we are looking at. So here we go. Part A. It says straightforward as this. John increased his trading card collection by 5 cards. He originally had 15 cards. What is the percent increase? Okay, so how much did it change? Well, he increased it by 5. He originally had how many? All right, the original amount. He had 15. Now, he does have 20 cards right now. But again, we're using the original amount. And then, yeah, we're going to change it into a percent. So you could reach for your calculator, change it into your decimal, and then change it into your percent. The other thing to keep in mind is you could use your proportion. Percent's always out of 100, and you could do some cross products that's here. 500 equals 15x. Divide both sides by 15, and then you can clickety-clack type that into your calculator. 500 divided by 15. Ooh, 33.3 repeating percent. 33.3 repeating percent. Not rounding here unless told to do so. If we think about it from the other side, that 5/15, that is 3/10 repeating. And then if you change that into a percent, hello, there you are. All right. So yeah, that's what we're looking at here. Again, they're doing a separate one with this amount of decrease. Who cares? The change. That's all we want to know is the change we're looking at. So let's see here. Ken said that he's going to reduce the number of calories that he eats during the day. Good for Ken. Ken's trainer. Wow, Ken's working out. Nice. Asked him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of the normal 2,500 calories per day until his next visit. Did Ken reduce his calorie intake by 7%? Okay, just fine. Okay, so change over the original. Change over the original. So 2,200, and then his normal was 2,500. So it changed by 300 calories. Now, what we got to figure out is what was the original amount. Well, remember, he wanted to lessen the amount. So that's the new. So that's not what I want. The 2,500 is your original. So again, you could change it by doing x over 100 and doing some cross products. You could just take that 300 divided by that 2,500, and then hey, there's your decimal. It just kind of depends on what you like working with, a comfort level that's there. If you do the cross products, you'll end up with 12% for an answer. If you do the fraction method, and you'll get 1200ths, but then you'll need to change it to 12%. So if you don't like changing those, then set it equal to x over 100, because percent is always out of 100 we're looking at. Let's see if there's anything else that we're really interested in here. Let's see here. Here we go. Population of cats in a rural neighborhood has declined in the past year by roughly 30%. Residents hypothesize, all right, I was worried about that word. I don't know if I was going to pronounce it correctly. I think I did a good job, though. That this is due to wild coyotes preying on cats. Oh my goodness. All right. The current cat population in the neighborhood is estimated to be 12. Okay. So remember, we've got the change all right, over the original is going to then result in that percentage that we're going to be doing here. So I've got 30%. It's declined by 30%. That gives me the percentage that we're looking at. Okay. Do I know how much it's changed? No. Do I know the original one? No. I know what the current cat population is. So this is where we just don't want to throw stuff in and be like, oh, I'm just going to use the formula that's there. All right. Um, yeah, so I don't know how much it's changed. I don't know what the original amount is. Again, currently there's 12. That's not the original. That's what I'm solving for. So I don't know what the original is, but I don't know how much it's changed either. So we got to go back and really start to look at what's going on here. All right. So here's where we're going to be after. Because this doesn't work, because I've got what we call two unknowns, what I want to realize here is that if we are declining by 30%, think about a sale price. If you get to take 30% off of a shirt that you're going to buy, what that means is you're actually finding 70% of that amount. All right, because what's percent always out of? Nah, 100. So if something declines by 30, the result is you actually have 70% of it. So what we're asking here is 70% of what number will result in 12. Okay, so let's look at this. This 12 is actually the part. So we're going back to that idea of, hey, part is percent times the whole. Whole being the original amount. Now, again, the key thing here is this 70%. Because it declined by 30%, that means it's actually 70% of that original number. So you've got to watch this problem here and not just start chucking things into locations here. So now because of this, I'm like, oh, 70%, so 0.7, sorry for the decimals there, times x has to result in 12. So we're going to divide both sides by 7/10. Reach for that calculator. 12 divided by 0.7 and go! 17.14285. Okay. Let's go back into the question. Approximately there. Yeah, all right, because we're not going to know the exact amount. Those crazy cats running around the neighborhood. Yeah, so I get x equals 17.1428. Again, I'm going to say approximately. Simple there. Yeah, not an equal sign. It's a wavy equal sign. That's an approximation symbol. So approximately 17 cats is what we would end up saying there. All right. Quality question there. And again, we want to understand that, hey, you just can't grab and chuck things in. You've got to make sure that it's matching up with the information that you've given. Good question there. All right, people, that's it. We're out of here. We'll see you later.